In this session, I'll talk about progressive wave. Now, this is the equation of a transverse progressive wave. Now, we have two questions to answer. Question number 1, in 4 seconds, how much does the wave propagate? And question number 2, in 4 seconds, how much does the particle at x equal to 0 move? So, two are the two different questions, that is one is propagation of wave, one is movement of one individual particle located at a specific point, that is at x equal to 0. Now, to answer this, we have to first write the equation of a transverse progressive wave propagating in the positive x direction. The equation is y is equal to a cosine 2 pi x over lambda minus t over capital T. So, if we compare this equation with this equation, we get to know that A is equal to 10 meters, lambda is equal to 5 meters, lambda is wavelength, and T, that is capital T, time period, is equal to 4 seconds. Now, wave velocity v is equal to frequency times lambda, and frequency is 1 over time period. So, that is equal to lambda over capital T. So, this is the wave velocity. So, wave velocity in this case is going to be lambda is 5 and capital T is 4. So, 5 over 4 meter per second. So, in 4 seconds, the wave moves by displacement delta x is equal to v times 4, and that is equal to 5 over 4 times 4, which is 5 meter. So, the wave propagates 5 meters. Now, then we talk about the movement of one specific particle at x equal to 0. So, for x equal to 0, the equation of the particle is, so y at x equal to 0 is 10 cosine 2 pi, then this is 0 minus t over 4. As cosine minus theta is same as cosine theta, so cosine 2 pi times minus t over 4 is same as cosine 2 pi times t over 4. So, this is 10 cosine 2 pi t over 4. So, at time t equal to 4, the displacement will be, so displacement at, okay, now the position at x equal to 0 and t equal to 0 is 10 cosine 2 pi over 4 times 0, which is 10 meters. So, that is the position at t equal to 0. Now, position at t equal to 4 is given by y at x equal to 0 and t equal to 4 is 10 cosine 2 pi over 4 times 4. So, that is equal to 10 cosine 2 pi, and that is equal to 10 meters. So, the particle will be back to the point it started from. So, the particle is actually undergoing a simple harmonic motion. So, if we look at the motion of the particle at x equal to 0, it started from a height of 10 meters above the mean position, and this is the shape of the wave. Now, the particle started from here. In 4 seconds it went down to -10 and then came up back to the starting position. So, this is the equation of a simple harmonic motion with time period 4 seconds. So, in 4 seconds the particle starts from 10 meters above the mean position, goes down to the lowest point and then comes back to the starting position. So, although it moves through 10 plus 10, 20 plus 20, there is 20 down and 20 up, altogether 40 meters. It moves 20 down and 20 up. It moves 40 meters and goes back to the starting position. So, how much does the particle at x equal to 0 move? The answer is it moves 40 meters. 40 meters. So, in capital T seconds, the wave advances through lambda. 5 meters is wavelength lambda. So, the wave advances through 5 meters. In other words, the wave advances through one wavelength, while one particle completes one oscillation. So, that is the most important part about a progressive harmonic wave, and which is in one time period the wave advances through one wavelength while one particle completes one simple harmonic oscillation. Thanks for watching.